My name is Michael Yang. I'm the Senior Product Manager in Enrizu for Vector Network Analyzer. In this presentation, I'm going to show you three different ways to do the triple offset short calibration. One is optimum solution. The other one is if you pick the wrong lenses, what to expect from the equation. And the third one is you can design your own offsets for three different lenses, and then to come out to satisfy the boundary condition of the equations. So in this presentation, I will show you a triple offset short calibration method. Okay. This the equations. Equation 1, 2, 3 are the equations that you use to either select electrical length for A, B, and A plus B, or if you know the frequency of interest, and then you can also derive the electrical length as well. Okay, and A is equal to offset short 2 minus offset short 1, and B is offset short 3 minus offset short 2, and A plus B is offset short 3 minus offset short 1. So if you look at our shock line, we have a WR12, which is E band, and on the yellow line over here is where you enter the minimum frequency and maximum frequency. So for the E band is minimum 60 gigahertz, the maximum is 90 gigahertz, and then we have a phase velocity, which is the speed of light. And the lambda cutoff dimension is 2 times lambda cutoff dimension, which is 2 times A, which is 6.199 millimeter. And then there's a dimension A is 3.09 millimeter. And then the permittivity for waveguide is 1. And then cutoff frequency for E band is 48 gigahertz. The mean square roots of frequency, basically square roots of minimum and the maximum frequency, and that becomes 73.5 gigahertz. Okay, so below is the multiple line of selection of WR12. If I enter the line 1, 2, and line 2, 2.8, and the line 3, 3.6 millimeter, you can see the degrees. They are within the equation. For instance, for here, you can see as the mean square root frequency is 106 degree, which is within 180 degree. For electric length B is 106 also, and for A plus B 212 degree. In the equation is as long as below 320 gigahertz, 320 degrees, and we satisfy all the equations. So in this case, if you select the wrong length, for instance, I select the line length 0 and line 2, and line 3, 2.8 offsets. You can see they all violate the equations. For electrical length of A, it goes beyond 180 degree. For A plus B, it goes beyond the 340 degree. And then for 1.9 cutoff frequency, it's go beyond 180, and it goes even 525 degrees. So they are valid. So you can see later in the measurements, you can see some spikes in the S11 meg log meg plots. Okay, and then how you gonna design? You can, if you want to design your own calc kit, yes, you can design. So for instance, over here I select 2 and 2.65 and 3.6 millimeter. You can see the equations: electrical length of A, electrical length of B, A plus B. They all satisfy the boundary condition of the equations.